The next topic we're going to cover in section 1.1 is exponents. So on this slide, we have a multiplication problem at the top where you are multiplying the same number times itself. And anytime you do that, you can also write it in exponential form. So on the left side, when you write the multiplication out, that is called expanded form. And then when you write it in this form that you see on the right side, it is called exponential form. So the number that is getting multiplied together is the base. So in this problem, 2 is the base. And however many times you are multiplying it times itself, that is the exponent. So here we have 5 is the exponent, or sometimes that's called power. Anytime the base is negative or is a fraction, the exponential form must have parentheses around the base. So for example, if I want to multiply negative 8 times negative 8 times negative 8, then I can write my base as negative 8 and my exponent is 3, since there are 3 of them. But the parentheses must be around the negative 8 for me to know that if I were going to go back to this expanded form, that the negative would go along with the 8 each time. For a fraction, you also have to put the base in parentheses. That way, you know that it's the entire fraction 2/3 that would be multiplied by itself 4 times. If you wrote it like this, it would look like the exponent's only on the 2 and that it would only apply to the 2. So you can see why the parentheses would be necessary for fraction bases. We're just going to go ahead and jump right into some examples with exponents. The instructions say evaluate each expression. So I'm going to go ahead and write the expanded form out. You may not always feel like you need to show that step, but as we are learning it, we're going to go ahead and write it out. So 5 cubed means 5 times 5 times 5. And then let's go ahead and evaluate by multiplying. So I'm going to do 5 times 5 is 25, bring down that third 5, and then 25 times 5 would be 125. So 5 cubed is equal to 125. And that is pretty simple. However, a common mistake when students see a base with an exponent is to want to multiply them. So a lot of times when 5 cubed is in a problem, I'll see students write that that's equal to 15. So be very careful that you don't just try to multiply the base times the exponent. Number 2, 3/4 to the 4th power. And we have the parentheses, which tells us that the whole fraction, 3/4, is getting repeated with multiplication 4 times. And now I know we have not covered multiplying fractions yet. That is actually in the next lesson, but I'm going to go ahead and give you a little heads up on that. To multiply fractions, you just go straight across. So here I'm going to do 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. Or you could also do these two and say this is 9, and 9 times 9 is 81. And then on the bottom, you've got 4 times 4 is 16, and another 16. 16 times 16 is 256. And of course, if you don't know that off the top of your head, you can just work that out to the side. And then that is your answer. That fraction cannot be simplified. Number 3, we have an example with a negative base. So, because there are parentheses around that negative value, then the negative gets repeated along with the 2 5 times. So we're going to write 5 negative 2's. Now let's go ahead and start multiplying those. I'm going to do these two together would make a positive 4. And then these two we multiply would be positive 4. Then I have that extra negative 2. I'm going to pull it down. Then 4 times 4 would be 16. And 16 times negative 2 is negative 32. So this problem, negative 2 to the 5th, is equal to negative 32. Now on number 4, you may say, well, is that the same as number 3? Not exactly. They are going to actually end up with the same answer, but the work should look a little different. If there are no parentheses around the negative, then the negative stays in front and it does not repeat along with the 2. You could think of this, if it helps, think of that negative as a negative 1 that is multiplied by 2 to the 5th. Or you could just think of it as a negative sign that stays out front, just comes down, and only the 2 repeats. So then you've got the negative, or the negative 1, times, and you multiply all your 2's together, it's still 32, same as it was in the previous example, and you end up with the same answer. But your work must be correct. So to get full credit on problems in this class, the work has to be correct. You could think of that negative in this problem kind of like you do when you have a negative variable. So if I have a negative x, that's the same thing as a negative 1x or a negative 1 times x. And so it works like that with exponents. 5 and 6 are kind of like the previous two examples, except now the exponent's even, and let's see what happens with that. So on number 5, because we have the parentheses, we're going to repeat the negative along with the 3. And when we multiply those, that's going to equal positive 9. On number 6, there are no parentheses, so the negative just stays in front. Again, if it helps you to think of it as a negative 1, then you can do that. And it's only the 3 that gets repeated, 3 times 3. So then you have a negative 1 times 9, and your final answer is negative 9. So when the exponent is even, you will actually get a different answer when there are parentheses and when there are not. So really practice those to make sure you understand how to use the parentheses in these problems. Number 7, of course, 0 to any power is still going to be 0. No matter how many times you multiply 0 times itself, it's still 0. Number 8. This would mean 1 times 1 times 1 times 1, on and on and on, 95 ones if you were to write it out in expanded form. However, we don't really have to write 95 ones. If we just write a few ones here, we'll just put some dots, there'd be some more ones in there. 1 times 1 is 1, and that times 1 is 1, and no matter how many of those ones you multiply, it's still going to be 1. Well, let's put that down here. So, not necessarily necessary to write out any ones. We know that 1 to any power is going to still be 1. Now, if it's a negative 1, that's a little different. If the power is even, and we were to write out an even number of negative 1s, I'm just going to do 4, let's say, we can start pairing them up. And as long as we have an even amount, they're going to all pair up to become positives. So you would end up multiplying positive ones together and get a positive 1 answer. But look at number 10, we have an odd exponent. So here we had an even, here we have an odd. So again, we don't have to write out 37, let's just pick an odd amount. We'll do 5. So these two can pair up, become positive, and those two positive, but there's one left over that's going to cause your answer to be negative. So anytime you have an odd amount, you can pair them all up except one. There'll always be one negative left over, causing the answer to be negative. So at the bottom, we can generalize that. If it's a negative number inside parentheses with an even exponent, that's like number 9, then your answer is going to be positive. We'll just abbreviate that. And if you've got a negative inside parentheses with an odd power, like number 10, you will always get a negative answer. So that finishes our exponent topic. If you want to go ahead and practice the exponent problems in the homework, you can do that. And then we've got one more video to cover order of operations.